Welcome to the Real Python Podcast. This is episode 126. Are you interested in using Python in an industry outside of software development? Would adding a few custom software tools increase efficiency and make your coworkers' jobs easier? This week on the show, Josh Burnett talks about using Python as a mechanical engineer. I met Josh at PyCon 2022 in Salt Lake City, which he attended for the first time with several coworkers. He suggested we do an episode to shed some light on ways Python is being used professionally by people who aren't primarily programming for a living. Josh works as a mechanical engineer at an equipment manufacturer, where he needs to perform repetitive tasks and generate copious logs. He explains how he moved his team away from MATLAB and towards using Python. We discuss his progression from writing scripts to developing packages and eventually hosting his work on PyPI. He also shares his explorations with CircuitPython for personal and professional projects. This episode is sponsored by Deepgram. Deepgram is the preferred speech-to-text API of Python developers. Get accurate transcripts from any audio with features for understanding. Try it by transcribing 200 hours free at deepgram.com/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Josh, welcome to the show.
I'm glad to be here. Thanks for having me, Christopher.
Yeah, we ran into each other while I was working at the booth at PyCon in Salt Lake, and you said you had been a listener to the show, so thanks for being a listener.
I was happy to.
And then we started talking about what you do, that you had kind of brought a team of people from your work to PyCon. So maybe we could talk a little bit about that, your experience of coming to PyCon, and then we were talking just before we started about how you were interested in coming to PyCon 2020 because you live in, or used to live in Pittsburgh.
Yeah, I was interested in coming to PyCon, even though sort of my background, as we'll continue to talk about here, is a little kind of non-standard for the typical Python or PyCon crowd. I feel like a lot of people that come to PyCon and are usually a programmer background. You know, they either come directly from programming or they are now, of course, now lots of data scientists, but a lot of times their job title maybe is they're some sort of a software developer.
Yeah, absolutely. Yeah.
But I'm a mechanical engineer, and most of my team is various types of engineers. So mechanical engineering, electrical engineering, or systems or process engineering. So a bunch of us will use programming as one of our tools in our tool belt, but that's not our job description per se. It's just something we use to accomplish the rest of our tools.
Yeah.
Yeah, I was excited to try to come to PyCon back in 2020. I was looking forward to it, and then obviously COVID happened, so that didn't happen. I was pretty bummed then when not only that year, and then the next year was canceled because, I was looking forward to going back to my hometown, and
I
was looking forward to going back there, and I went to Carnegie Mellon, so I was going to go back and see the campus and see how things were there, and that obviously didn't happen. So I am excited that I believe the current plans are that after this next year, repeating at Salt Lake City, they're going
to... 24?
They'll go back to Pittsburgh. Because it's a lot of effort, is my understanding, to plan a PyCon, to say the least. And they get to reuse all those vendor relationships that they had been setting up that they had to cancel. They can sort of step in where they left off. So that's great that they're able to do that.
Right. And then I think that's why they keep doing it like 2 years in a row at a particular place. Yeah.
Cuts down on the overhead.
Yeah. Yeah, at least they kind of know what they're getting, hopefully, next year.
That's right.
Can optimize.
So I was happy to be able to bring not just myself to PyCon this year, though, but instead a whole team of people from my company. I was happy that I was able to pitch that to kind of the decision makers. And they said, yeah, we've got money in the training budget. And if people are interested, we can do it. So kind of looked around to see who was interested in coming.
What kind of work do they do? The same kind of thing, mechanical engineering? Or is it a mix?
We had people that came. I think there were 4 of us that were mechanical engineers. at least two that were called process engineers. So they kind of work in the manufacturing side of things.
Mm-hmm.
And then we had two more systems engineers as well.
Okay.
So they're part of we're all part of the process of making new products. I work at a company called Werfen that makes healthcare diagnostic equipment, basically kind of specialty diagnostics. And they've got a few sites around the world, but my site in the Boston area focuses on different kinds of blood analysis.
Yeah, I saw the buzzword there of next generation instrumentation platforms. And I was like, okay, what does that mean?
Yeah, most of the time, if you're at a company that makes, lab instrumentation, then each of those products that you make, that you're working on, is usually based on kind of a platform that the company has previously developed. And you're taking something that's already been made and released, and maybe you're tweaking it, making some incremental improvements, or maybe just changing it a little to target a slightly different market, adding some new features or something. But it's fundamentally an incremental update to what you did before.
Okay.
But if you're lucky and you get some good timing, you at the company at sort of just the right time when they need to redesign the whole platform.
All right.
Both my last company that I was at and my current company now, it's happened where the product that they're selling is based on electronics that are getting pretty long in the tooth. You don't want to have to change that underlying platform too often, because there's a lot of investment that goes into writing the firmware, the low level code that runs these embedded systems.
Okay.
They don't want to redo that more often than they have to.
Can I pause you there? Like So I have a friend who writes for Real Python, Jim Anderson, and you might have met him at the show. He was everywhere at PyCon introducing people to me, but he works in video as a platform and does a similar thing of building firmware and so forth. And we were talking before we started a little bit about photography and how much that's just rapidly changed and updated, and almost sort of obsolescence is like just a built-in factor.
Yes.
In the case of the tools that you work with, what's the lifespan of a platform? I guess it would accelerate in the way that chips and stuff are changing so much now.
It's sort of the other way around. So with my current company being in the healthcare industry, it's all FDA regulated. And there's an enormous amount of effort that goes into qualifying your product, making sure that it does exactly what you say it's going to do. It does it reliably, and every time you're getting the proper results, because you're giving people diagnoses based on these results.
Right.
So the FDA, they're very stringent about their quality levels there.
Okay.
And as such, once you put something into the market, if you make major changes to it, or even not so major changes, you have to go back to the FDA and show them that these changes we've made don't affect the outcome of when you use the product.
Okay.
So they call that validation, and you want to avoid having to revalidate as much as possible, because it's a lot of work.
Yeah, sounds like it.
So as such, the lifetimes of these products can be in the 10, 15, or even 20-year span for a given platform.
Okay. And you guys are working on generally updating them and figuring out how to create a long-lived
That's right.
platform. Yeah.
Yeah, over the course of that 20 years, it's not just the same product that's the only thing you sell for those 20 years, but you put up the first one, and then you branch out and you base other things on that same platform. But now, we're starting to get to that, okay, these electronics are getting really old, and maybe some of them are going to go obsolete.
Yeah.
And just in general, when you look and say, well, given what electronics were capable of 15, 20 years ago, and then comparing that with what you can do with modern computing hardware, wow, if we sort of take this opportunity to redo the whole platform from the ground up, we can make it do a whole lot more, include a lot more automation, require less out of the user, much better user interfaces and user experience. So yeah, that's sort of the next generation platform is where you're able to rethink the whole thing and really have a lot of fun with it from an engineering perspective.
I would imagine that one of the shifts that would have come along is the connection to other computers and other platforms, as opposed to it being a bit more of a standalone type of,
yes,
especially certain medical equipment.
Yeah, definitely in the last, say, decade, you've seen more and more in this kind of laboratory instrumentation space, where for big, expensive equipment, not necessarily for small things, but for equipment that's going to be in the tens to hundreds of thousands of dollars.
Yeah.
they'll have ways of networking those together, both for whatever kind of test data that it's creating. It's able to store those in centralized databases, but then also where you're able to centrally monitor those to verify that they're in good working order. If you're a big lab that has 20 or 30 or sometimes 100 of like say pieces of like chemical analysis equipment that are running, and these things cost $100,000 a piece, then you want to make sure that they're all getting as much uptime as possible, and your investments are worth it. So they'll invest in some kind of central monitoring software that's able to check them over the network and see which ones require maintenance, so you can plan those things out ahead of time. And that just wasn't possible with older technology, right?
10, 15, 20 years ago, it was like a spark that people thought of, but wasn't necessarily being implemented at the time.
Yes.
So that's really interesting to me that, number one, that you kind of have to think about really long-lived products and platforms and so forth. But then also that you kind of came to me because you were like, hey, we're really getting into Python. And so I kind of wondered, like, maybe we could do a little just super quick background on your background in programming.
Yeah. So when I went to school, I graduated from my undergrad in 2001. So kind of right in the middle of the dot-com boom was going there. And as an undergrad, I had to take, for the engineering curriculum, you had to take the intro to computer science. And I think at the time, you had the option, depending on sort of which professor you had, if you were either going to learn C++ or Java. And I would say, thankfully, I ended up with C++. I didn't have to go too deep into it, but either way, it was, so C++. And that was sort of my first experience with that level of coding. I mean, as a little kid, I think I got exposed to like Logo Writer and QBasic and some of those kind of things I was playing around with on our home computer, but didn't really do a lot with that. So, one semester of C++, and then another part of the engineering curriculum there at my school was we had a numerical methods class. So you'd look at how to do numerical analysis, numerical processing, and we would look at implementing different algorithms, whether that's for optimizing things, or in that case, we would do half of it in C++, and half of it, we started using this platform and language called MATLAB, which people who aren't sort of in the industry aren't necessarily familiar with what MATLAB is. So that's something called, it stands for Matrix Laboratory. And it's both a language, and then it's also a runtime environment that's optimized specifically for numerical computing.
Yeah, it's become an even bigger platform as they've kind of gone and tried to find additional like solutions like cloud hosting and other things like that. Yeah.
And it's a decent language for like a lot of kind of plain vanilla data analysis. Or even, I remember I had a friend who was working at a company doing some of the early gene sequencing, and they were writing a lot of their algorithms in MATLAB. So it's kind of scientific computing. It's a pretty popular place to do it there. As soon as you need to get outside of Excel, you could do maybe raw numerical processing in Fortran, but you're not going to do data visualizations with it. And once you needed to get to that kind of heavy duty number crunching and data analysis, then MATLAB is one of the main tools that people would turn to. So I ended up using MATLAB more and more. And by the time I graduated school, I think I ended up my final semester using it in pretty much every one of my classes. So I was getting pretty familiar with it there.
So they were in a lot of the universities as far as the certain programs you're in the program you were in was mechanical engineering?
Yes, mechanical engineering, and the MathWorks, which is the company that makes MATLAB, they're very keen to get the new graduates very familiar with that, because that's one of the tools they want to use, right? So they would give us free licenses while we're in school, which is good because it's extremely expensive once you're out in the professional market. It's a tool. They pitch it. It has a value proposition. Like, yes, it costs money to use, but it's going to save you money in developing whatever product you're doing. If you're doing some kind of digital signal processing, developing algorithms around that, or controls work, then they have all kinds of specialized add-ons. They call them toolboxes that are sort of targeting various particular computing tasks.
I can think of lots of little industries that are like that, having worked in video and audio and the sort of, if you were going to go to school, in my case, I worked at a school for recording engineers. students had to come out and know Pro Tools. They had to be familiar with it. Or if they were going to work in film, they would need to know Avid and be familiar with those
Sure.
platforms. Even though there were other platforms that are around, it made sense. And then we literally would have like certifications for those kinds of things. And so there's always that kind of interesting hook, that's part of it. And there are, side cases where other things are popping up. And I thought that was kind of interesting that this is one of the focuses that we thought we could talk about, is that you started to transition away from using that. Maybe we could talk about how you were using MATLAB at your company now or previously.
And
then
my previous company,
kind of we get into that transition. Yeah.
Yeah. So I was doing a lot of like log file processing, or I was collecting data in the lab. A lot of what I end up doing, I'm creating or designing new parts. I'm a mechanical engineer, right? So I'm not just making circuits and things, but I'm making physical parts that we design with CAD software. And then once we are putting everything together, we need to start testing it and making sure things work properly. And a lot of the equipment that I design and work on has lots of automation. It's lots of motors and gears and things that are moving mechanisms around.
Okay.
And we were collecting some information from those, basically using some small embedded computers that would give us log files. And I needed to parse those so I could pull the data out of those and create some graphs and kind of make sense of what the heck was going on with my test setup. I was initially doing all that in MATLAB, but my workflow was that I would go to this lab in another part of the building and run all my tests on some computer there, on a computer that I wasn't responsible for. It was a different part of the company, so I couldn't just install whatever I wanted on that computer.
Okay. Its job is specific for doing that sort of work. And
yes, and I couldn't install, say, MATLAB, because there's licenses required for every install. And like we said, it's thousands of dollars per seat. So they weren't going to install a license just there for me to do that.
Okay.
So I would go to that machine, I would capture these text files, log files, put them on a thumb drive, and walk back to my laptop or walk back to my desktop at the time at my desk and fire up MATLAB and do my analysis. Well, that's a lot of walking back and forth and pretty inefficient, right?
Good old sneaker net.
So I had started when I was in grad school, just before that job, I had played a little bit with Python as part of some projects. So I had gotten a little bit of exposure to it. When I was in this particular situation, I'm thinking, I wonder if Python would be able to serve the need here. So I started looking into that. And sure enough, this is in the early to late 2000s. And the numerical computing story for Python was really maturing heavily at the time. So they had consolidated, it used to be not just NumPy, I think it was Numeric, I think was another library at the time that were kind of competing within the Python space. So they had consolidated to just NumPy.
Okay.
And Matplotlib was coming along nicely. And I found, hey, yeah, all the things that I was using MATLAB for in this case, which were not this super specialized code that MATLAB or the MathWorks tries to hook you on, but it's just the plain vanilla, I need to open a file and parse it and make plots from it. Python was able to do that very well for me. And in fact, I found a portable distribution of Python that I was able to run right off my thumb drive that had an IDE associated with it that's no longer around now. But I could just walk down with my thumb drive, use that same machine that I didn't have the ability to install software on, and just run everything I needed to right off the thumb drive.
Okay.
And then right there, I could...
The executable was there and yeah, neat. Okay.
Exactly. I could capture the files. I could do my data processing all right in one place. I didn't have to worry about any licensing fees. And so that was kind of the gateway drug, the foot in the door for, hey, I think this could work here. And and then sure enough, I kept finding more and more uses for Python, usually doing various kinds of data analysis, but especially cases where I was not at my main PC where I had that MATLAB license. And then I found that over time I was opening MATLAB less and less and less. And then finally I realized, I can either have the company cancel my particular MATLAB license entirely, or I can give it to someone else because I'm not even using it. I haven't opened it in a year or something at this point.
Wow. How long ago was that?
That was now over a decade at this point.
Oh, wow. Okay.
I don't even have MATLAB licenses anymore at my new job because I do everything I need to within Python.
Nice. I wonder about a bunch of things there. I didn't even write this question down, but I was thinking okay, so that's Python 2, I'm guessing.
Yes, I started probably 2.5 or 2.4, 2.5, somewhere in that range in grad school.
Okay.
and then probably 2.6 around that time.
Maybe we could just do a brief thing about, over time, was it hard for you? As a like we talked about, not being like a software development shop where you have like deployed software and things like that. It sounds like it's fairly localized software. So transitioning to something like 3 maybe wasn't as painful as a company that would have to look across a set of architecture across an entire organization changing.
Correct. Our usage across my current and previous teams is pretty, like you said, localized. We don't have a lot of software we're deploying anywhere.
Okay.
We're usually writing it for ourselves or for a couple people on our small team that we're sharing it with.
Okay.
And so there wasn't a need to say, I need to make sure that I stay compatible with 2.7 because that's what we have out in the field. So instead, no, I stuck with 2.7 until the main libraries that I needed to run were really ready to go with that.
Right.
So
that makes sense.
Matplotlib and NumPy especially, and then a couple others that I had used. But I probably jumped in around 3.4, 3.5 finally. Okay. And then, of course, once F-strings hit, everyone wanted to go to 3.6.
There you go. Yeah, especially with the kinds of work that you're doing.
Yeah.
I would guess you're kind of one of the things that's come up a lot lately is debugging programs and so forth. And it sounds like you're doing a lot of logging. But do you still often use like just F-strings to kind of like get things up on its feet and see how it's working?
Oh yeah.
Okay.
Oh yeah. I print out F-strings all the time. They're nice and quick and dirty.
Yeah.
If I'm making a small script that's not too hard to sort of fit the whole thing in your head at a time, then yeah, printing is totally fine. It's once I am building something that is bigger, that's going to need to import from a whole bunch of different locations, and then I'll start using logging. Like Log Guru is a great package for doing very easy logging within Python.
Okay, I'll have to write that one, get a link for that one and include it.
Yeah, it's nice. You can just import it, and basically everything else you need is right there. You don't have to do a ton of configuration. It's based on the built-in system, Python logging, but it just makes it super easy to use right out of the box.
It's somewhat drop-inable in a way.
Yeah, it is totally.
Okay, so you on your own when it started doing all this,
yes.
What was the initial spark? I mean, you mentioned some of it, but was it that you had played with Python before and it was like a fairly easy language for you to wrap your head around? What were the things that made you choose that?
Yeah, when I was in grad school, I was taking a robotics class and was still using MATLAB for pretty much all my grad school numeric computing needs. But in this particular class, I was starting to try to implement some particular algorithm, the details of which are lost to time. But it required some data constructs that didn't really exist in MATLAB. And I was trying to figure out how I wanted to do that, involve sorting and red-black trees. And again, the details I probably don't remember much of them at this point. But I found some references to a Python library that implemented them. I thought, oh yeah, I remember I played around here and there with some Python. Let me see how that works. And that's kind of what really got me going with it at that point.
Okay.
And I ended up using it for that whole project, and it was doing some mapping of a space with small robots that had little sensors on them, and trying to make sense of the
early Roomba mapping style kind of stuff.
Yeah, very much like that.
Cool. What is the syntax of MATLAB like? Is it something that's easy for people to wrap their heads around?
It's very similar to Python.
Okay.
Yes, it's I think the underlying runtime engine is implemented in Java, and so sort of a lot of the style of Java kind of leaks over into MATLAB, but it's lots of dot syntax, and not tons of extraneous extra characters. So it's not like Perl or anything like that.
Okay, cool.
So it was making that transition from the MATLAB syntax over to Python was pretty straightforward.
Python developers from companies like NASA, Volley, and Spotify chose Deepgram's speech-to-text API for accurate, usable transcripts to power their voice bots, podcast analytics, and video platforms. Deepgram automatically transcribes any audio with understanding features like summarization, topic detection, and language detection, so you can do more with your voice data. Get an API key and transcribe your first 200 hours for free at deepgram.com/realpython. So then I guess I'd like to kind of journey deeper into your sort of almost evangelism inside your organization for Python, kind of being this champion. What were the kinds of things that you were suggesting to other people? And I guess maybe we could start with, you were using it for these sort of logging tools and other things. Were there other projects that you started to implement going beyond that?
Yes. So I ended up using Python in a lot of kind of small ways and large ways.
Okay.
Early on, maybe something that's kind of a typical task for me was, we had a mechanism that was moving a probe along two axes, so X and Y, sort of along a table.
Okay.
And we wanted to measure how consistently and accurately that mechanism would move to a given location, just as part of making sure that it worked well enough. So we had this basically a spring-loaded gauge that you would fix it in place, well, with a fixture, I guess we call it in machining, but it hold it in place, and then you would move the probe up against it from left to right, and it would be able to measure, okay, how far are we compressing this little spring-loaded tip on it? And it's, down to, thousandths of an inch. So really, really accurate stuff. If I was going to have to manually do this, I would be, controlling that mechanism, tell it, okay, move over so it touches the gauge, and then I have to write down or something, whatever the number was on the screen, on the LCD screen, and then just keep doing that manually a bunch of times. That would be really tedious.
I can imagine.
So fortunately, with this particular gauge that we had a digital readout on it, and it also had a connector on it that you could plug in an RS-232 adapter, and talk to it that way with your PC. So, and at that point, it just treats it like a keyboard, I think. So every time you took a measurement, I think you would send it a character, and then it would respond back with whatever the current measurement was. So, okay, now I've got a way to talk to it programmatically using the PySerial module for talking over serial ports. And I can combine that with also being able to programmatically control this mechanism. So now I could just write a simple for loop and have it move over to the point where it should be, making contact with that gauge, take a reading, maybe with a half-second pause or something in there, and then have it move away and then come back and do it again. And now I can take thousands of measurements and get, really nice, statistically significant data without having to sit there and
get coffee too.
Yeah, exactly. Right. So that's just one small example. And you do something like that, and people oh, that's kind of cool, be able to do that and get some good data.
So people are watching you?
Yeah, people would see that. And then we also had some bigger things as well. I had a piece of equipment that we would use in the lab for measuring how much torque you get out of a motor. We have these small stepper motors, they're called, and we want to verify that they're actually strong enough to do what we need. So
they need to hold at a certain amount.
Yes. So because these are the motors that are actually driving your mechanisms around. So if you're trying to move something in X or Y or rotate stuff around, it needs to be able to do it fast enough for. Right. In this case, it was. I worked at a company that was making chemical analysis equipment that you would put in little vials that are full of some kind of sample that's a liquid that you need to analyze, and then there would be an automated needle that would move over and kind of poke in the top of the vial and pull some of that sample out to inject it into the rest of the system and analyze it.
Okay.
So, there's lots of motor axes going on there, and you want to make sure that it can move fast enough for your throughput reasons.
Yeah.
So, in any time that we either are speccing out a new motor, or maybe we want to replace an old motor that's already in use in our product, but we want to have a second supplier come online, so we're not just beholden to having one supplier that sells us a motor. We want to verify that, this new supplier, they're not just blowing smoke, but that actually is, produces the right amount of torque that we need for it.
They will give you a set of them to
we get some samples
to test in your purposes.
Yes.
Okay. Yeah.
And it's especially important with stepper motors. The circuit that you're using to drive them will have a direct impact on how powerful they are. So you can't just take the manufacturer's word for
in the spec sheet or whatever.
Yeah, the spec sheet, because when they test it, that's with whatever driver chip they were using, and that may not be the same as the driver chip you were using. So you really need to use your own circuit in that process. So we bought some equipment from a company that would allow you to take torque measurements But it was really manual process. Again, I think you see the pattern happening here.
The theme.
It was a manual process, and either you or your poor co-op or summer intern would have to sit there for many hours straight and taking these measurements. And it involved pushing a bunch of buttons on this big machine and then looking at a digital readout that was coming off of it, and at the same time bending over to your laptop, usually in the lab, and typing some commands that would tell the motor to spin up to a certain speed or something. So we were able to buy an expansion card for that piece of equipment that, instead of just having buttons and LED readouts and a digital readout, now we had digital inputs that mapped to those buttons, and we had digital outputs that would correspond to various LEDs that would, indicators on it, and an analog output that would, produce a volt, 0 to 5 volts output corresponding to what normally would have been on that digital readout.
Okay.
And so now we could take that and combine it with a data acquisition box from someone like, say, National Instruments or some other companies that also have a Python API. And now we're able to use the laptop to basically take all the same readings that we would have had to just manually write down by looking at the screen. And in fact, we get much better data as a result out of this, and we get it at a higher sample rate.
I can imagine.
And
the consistency would be
much better,
way better than the sort of human, I don't know, slop, whatever you want to call it, that would be involved in there.
So then, once we were able to not just automate the process of running the test and collecting the data, but then I was able to take that and make a GUI for it, driving the whole setup using PyQt, and then this really cool module called PyQt Graph, which you can use for real-time data visualization. It's much faster than something like Matplotlib, which is, Matplotlib is great for your publication quality graphics, but it's kind of slow, where this is something that you could have graphs that are updating on the screen at 30 hertz, no problem.
Yeah, so I was thinking more real time.
Yeah,
like and as it's running. Okay,
it's really smooth, and it allows you to pan and zoom around. It has a whole bunch of that functionality built right in without you having to implement it yourself, and it's all using using Qt under the hood, so it's in C++ and it's fast and it's very efficient. So while it's updating the, multiple graphs on the screen at 30 hertz or more, it's really fluid. It's using like 3% of the processor power, so it's no big deal. So in the end, I have this really nice test setup that I can show anyone how to use, and where previously you'd have to sit in front of it for possibly multiple afternoons because you wouldn't want to do it all day long to get all the data you wanted. Now you can set it up, and then you walk away for 10-15 minutes while it goes through and does all the tests.
Cool.
And it does them without messing up, which you surely were going to do over that span of time.
Sure. Yeah.
So when you show people things like that, they start to see that, this tool has a lot of value. We certainly we can make that work.
So it's like kind of like this, in order to get other people on board, like you mentioned that the organization you're with now, like they're sending people to PyCon, and you were able to say, hey, let's bring a whole batch of people. Was there a process of showing other people, or would they just see the results of what you were doing and then come over and be interested? Or?
A little bit of both. So I think it was a lot easier to sell the company on the benefits of our various engineers having a good Python background when they saw what we were able to accomplish, even though we were working remotely during COVID.
Oh, interesting. So the last 2 years.
Yeah. So we were not full-time remote, but I am a mechanical engineer. I do have to make physical things. I need to be in the lab and put them together with my hands. But
I imagine
I was able to kind of set up some things so that I could run equipment remotely. So I set up some webcams and set up your remote access for my computers that were running some equipment in the lab. Then I was able to control everything using Python. Even though I'm logging in remotely from home, I'm basically writing some control programs that would make these mechanisms that I work on go through the various tests that we need them to do. But I was able to work on all of that from home and still get a lot accomplished, even though I wasn't right there in the lab. Now, that's not necessarily the remote portion of that isn't necessarily the success story for Python. But the fact that the work was happening at all, whether I was there or not, that was really the success story with Python, where we were in pretty early design phase of this project, where we didn't necessarily have robust and complete firmware. So that kind of low level code I was talking about, that is what will drive this equipment when it goes out into the field. When we release this and sell it as a product, they're not going to use my Python code to drive this thing, thankfully.
That's what I was thinking. That would still be in, like a C or some other kind of
typically
thing.
C or C++. Although there are lots of places now where Python is coming in there as well. We can talk about that another time.
Sure.
But that C++ code wasn't really ready. There was some initial low-level stuff that was ready that would allow me to move some motors. But our team had exposed some Python bindings, basically a Python API, where I could control those individual motors, or I could read individual sensors with Python. And so even though they don't have the full behavior of the system implemented in C++, they sort of gave us all the building blocks necessary with Python.
All the touch points, if you will.
Yeah. And then we, as the non-firmware team, but the teams who were familiar with how the thing is supposed to work, could go ahead and kind of prototype up a lot of that behavior.
Cool.
And verify that, it does these mechanisms that we've been designing, that we're building, they work the way we want them to work. Then when our management sees, we're able to accomplish a lot even at a very early prototype stage with Python here, they saw the value in that pretty quickly. So then when I'm saying, hey, if we can send some more people to PyCon, we can get more of us up to speed on a lot of this.
Yeah. Have they paid for training in other situations?
We have,
We've
done, I think over the last year and a half, we've probably run 3 or 4 different training courses where we bring, we're working together with an outside company they have a remote instructor, and they have a nice online platform that we use for the actual training course itself.
Cool.
So the course is real time. It's not live in person, but it's live remote.
Yeah.
We've done that a number of different times. We probably have had 40 or 50 people at least go through that training now across different parts of R&D. And we're actually going to run another one in another couple weeks. So yeah, the company's been real happy with that.
I can imagine that you've gone on a journey that a lot of Python, developers or people who are kind of experimenting in it, where you start with what would just be very script-like stuff, just this file that just runs straight through. And then you've progressed into creating packages, because one of the things that we'll talk near the end about is that you have like a little library of stuff on PyPI that is stuff that maybe you use in work somewhat, but also stuff that you thought you could share that would be, I guess, more widely usable outside of like maybe just inside the organization. What was that journey like for you, and like how far along did you start learning about the methods of packaging and that kind of tooling?
Sure. My early work in Python for sure was just, they were scripts. They were barely programs.
Yeah.
They accomplished one particular task. You run the file straight through, and that was good enough. And then, as I started doing more and more of it, you start realizing, hey, there's code here that I'm either consistently copying and pasting across multiple projects. How can I just pull that out into a separate module so I can import that? And then eventually, those parts got sort of self-contained enough that I was not only reusing them across my own projects, but then with my colleagues as well. It's like, hey, here's a module that I wrote for parsing data a certain way that seemed like it would be useful.
Okay.
And so I eventually got sick of having to constantly respond to, hey, what's the newest version of that code? Because I also I wasn't as familiar with things like Git or GitHub at the time. So I think I started with Mercurial for a long time, was using that for my version control.
Okay.
Before eventually finally giving in and moving to GitHub and everything. But my colleagues would be asking me, okay, what's the latest version of that file? So I keep sending them that. And then eventually I said, well, I wonder if I could, this isn't anything that's proprietary. Like, it's pretty generic, and I probably can just release that to something like PyPI, and then I can just tell them, hey, go pip install it, rather than constantly bugging me for the newest version of it. And it also makes it easier for me, right? If I'm setting up a new test setup, I don't have to go track down, okay, where did I save the newest version of that file? Instead, I just know,
Makes it very portable, right?
Yeah. I started learning about it's sort of some of the more best practices, whether it's just a requirements.txt or whatever, so that if I'm sending someone my code that's not necessarily a module they're going to install, but they're just trying to look at a data analysis that I did, then I can list, here's all my requirements and requirements.txt. And that way
Nice.
they know they can just pip install that in a new virtual environment and they're kind of off and running. So it took time, though, to get to that for sure.
Yeah. What does that timeline look like, you think?
So, I look back at this particular module I'm thinking of, the first one that I ended up releasing to PyPI. My first release to PyPI was in 2016. And amusingly enough, it was immediately, like, same day, followed up by 3 bug fix releases because I had gotten some of the metadata wrong in PyPI.
That's always the way it happens.
So, but it wasn't my first release of that code internally. So actually, it was released at version 1.3 because I had some version 1.0 that was just internally that I was using as my own version numbering system before I released it publicly. But yeah, so I had 1.3 and then 1.3.1, 1.3.2, 1.3.3 right away. But if I look back at that code, 1.0 would have been in 2010. So that was the first time I started kind of putting at least that particular module together into something that I could easily package up and send it to someone else as, hey, here's a standalone module that you can import these sort of utility functions from. It was for implementing scanf. So, in C or in, of course, I was coming from MATLAB, there's a function for just taking a string, and maybe that string has some numbers in it interspersed with some other text. And you want to be able to just pull those numbers out of it. And you can kind of provide the scanf function a template saying this is what it should look like. And then there's a couple special formatted strings that you put in there to say, oh, there's an integer here, so I'm going to stick a %i here, or if it's a floating point number here, so there's %f there.
Okay.
And it's just really simple and straightforward to use. And like I said, it's common. It's coming from C. They use that scanf function, and then in MATLAB there's a scanf function as well. So I was familiar with that.
So familiarity's there.
Yeah, but I was looking around, again, this is back in 2010, looking around and couldn't really find any packages that did that off the shelf, nothing in PyPI. And the solutions that the responses that you would get from whether it was looking at some of the core team dev discussion boards, and they basically said, yeah, you should just use regular expressions for that. And that's true. You can use regular expressions for that, but it felt like using a sledgehammer to try to push a tack in. Like, it was just really over.
And there you have to go through the arduous task of learning regular expressions that you'll eventually forget.
Yes, and you'll forget them every time.
Which I have done probably 3 times, right?
Yes. And some of those can be surprisingly complicated to come up with a robust regular expression that will work in all cases where you're trying to look for a floating point number, even if maybe it has scientific notation in it. It gets pretty complicated. These are things that, even if you're going to do it as a regular expression, you're going to end up either copying and pasting that code all the time, or you're going to put it into a library.
Right.
So I ended up finding a recipe that someone had written on, like, Active State or something that did what I was looking for. And so I took that and kind of cleaned it up a little bit, made sure I put a link in the top of the file to where I had found that solution so I could go back and find it later if I needed to. Added a couple other formatting options as well that weren't covered in there that were part of the kind of scanf spec, and then packaged that up. So great, now there's a scanf package on PyPI, and it's actually pretty widely used. I was surprised to realize that when
That's cool.
I got an email, about a month ago now, saying, hey, this is a critical package. So I went and looked, and it barely squeaks into that category. It's like, I think it's the top 1% is considered critical, and it's like,
you got the PyPI message.
I got the message.
I've talked about in the news recently.
It was at like 0.9%. Yeah, it was barely in there.
Wow.
But yeah, I was like, wow, that.
So you're getting a key, I guess.
Yeah. Well, I turned on the 2-factor authentication. I didn't feel the need. I was worried about the key if I would lose them or whatever. So, whereas I already do 2FA with some other stuff and just use an authenticator app. So I figured I can turn that on. That's no problem. I didn't see it as being too big of a hassle. So
one of the things that a lot of organizations do instead is then host the stuff internally. Mm-hmm. And you said you felt that there was nothing proprietary within the first couple libraries that you've put up on PyPI. it just made more sense to not have to think about, like, I would guess maybe the organization wouldn't have the infrastructure set up to create their own little solution for like hosting packages and so forth, potentially.
Correct. So the last company I was at, they were starting to go down that road where they were doing enough kind of internal Python releases of packages that they set up. Initially, they were using a DevPy server, which for people that aren't familiar with that is basically a small kind of local mirror, not even mirror, but a small version of PyPI that is whatever packages you put in there.
Yeah.
And then you can configure your local pip so that it will first look at this local DevPy server before it goes out to the global PyPI server. So that way, even if you have some namespace collisions or something, it'll pull the local one first.
Okay.
They started off doing that, and then they eventually moved to a solution with Artifactory, I think, which has some plugins for handling Python packaging. But my current company doesn't do anything like that. We're looking at some of those solutions. I definitely see why you would do that, because for sure, if you want to package up some proprietary code but still make it easily pip installable, how do you do that? Obviously, you want to have an internal method of doing that. And we'll probably move to something that also does some mirroring of the external PyPI packages as well. So if we have certain dependencies that we need to start relying on, then at some point, if that starts working its way more into production, then we'll ostensibly set up a better production workflow there, where it's maintaining local copies of all those PyPI packages that you have dependencies on, so you're not worried about something disappearing.
Yeah. What was your experience like? You've mentioned a lot of it, kind of like experimenting and, kind of first releases and having to do lots of updates and so forth. The tools that we're using, has that situation, like setup tools and some of these other kinds of things that have been changing over time for doing packaging, how's your experience been with that? And do you have a solution that you're happy with now?
It's been a little difficult getting going. At first, again, this is 2016 was when I first put my first package up on PyPI. So the documents were okay at the time. They've gotten much better since then.
Okay.
Especially there was a recent major update to the whole Python packaging kind of recommendations to reflect all the pyproject.toml stuff. But as I was trying to understand, so how does this setup.py file work? How am I supposed to put that together? And I think I found a template that someone else had used and kind of put forth as here's the best practices setup.py. So I took that and adopted it for myself. And that mostly worked fine for me. Every once in a while, I'd have to go back and revisit that and just make sure I remembered how the process worked, because I'm not putting out too many releases of the things that I have on PyPI. So it's not like I'm hooked up with CI, CD, and every time I check something into GitHub, it automatically goes to PyPI. So I do have to remember what that process looks like. But I made some notes for myself of what exactly the steps are for me, using Twine or something to update it. Now with the changes to pyproject.toml, I need to start taking a look at that, because that is sort of it's clearly the way of the future there that you're supposed to do it. So I need to start looking into that.
Yeah, I'll link to some resources on RealPython for you. This week, I want to shine a spotlight on another RealPython video course. It's titled Building Python Project Documentation with MKDocs. The course is based on a RealPython step-by-step project by frequent guest Martin Broyce. And in the video course, instructor Darren Jones shows you how to work with MKDocs to produce static pages from Markdown, pull in code documentation from docstrings using MKDocstrings, follow best practices for project documentation, and use the material for MKDocs theme to make your documentation look great, and how to host your documentation on GitHub pages. I think using tools like this can make what seems like a daunting task so much easier. And I think it's a worthy investment of your time to learn how to automate production of your project's documentation. Your users will truly appreciate it. RealPython video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So one of the things that we talked about at PyCon was that you've been experimenting with prototyping and using CircuitPython for that,
Yeah.
for some of the mechanical engineer things. Not only, work, but also kind of playing around with it at home. How's that going? And what do you think of CircuitPython as a platform?
It's fun to play with. Yeah, I had been reading about it and was trying to think kind of what do I want to try this out with and what opportunity do I have. And then during kind of early COVID, I was working from home, like I mentioned, a couple days a week.
Yeah.
And the room that I'm in at home has a pellet stove for heat because it gets pretty cold. It's kind of a 3-season room.
Okay.
And during the winter, though, it would get really cold overnight because we leave the heat off in that room. And in the morning, I would come in and turn that pellet stove on. And I found myself wondering, how long does it take this to actually warm up in the morning? And then once it comes up to temperature, it has some kind of thermostat built in it cycles on and off throughout the day. How effectively was it regulating the temperature in this room? I mean, come on, I'm an engineer. That's how I think about these things. So
there's got to be a solution.
That's right. So I ordered some stuff off of Adafruit, got a little itsy bitsy, M0 and a temperature sensor and a little small OLED screen.
Okay.
And made a little, just a little breadboard setup that would take the reading of the current temperature and humidity from that sensor and then display it on the little OLED screen. And it would also produce a little graph of what the temperature had been for the last 2 hours. So I could kind of see as I'm sitting at my desk and, okay, it's getting warmer. But if I want to look back and say, it's taken, a half hour to go up 10 degrees, it's very geeky, of course. And yes, I'm definitely an engineer, but it was fun. I really enjoyed doing that. And it was definitely a bit of an adventure there just because I found that a lot of the functionality I wanted was there in CircuitPython, and I could cobble together something pretty quickly that at least would read the temperature and then have a printout on the screen of just a number. But then the graph started getting interesting. There are some very, very rudimentary kind of drawing operations that are available within CircuitPython. And they've gotten a little bit better, but basically you can draw a polygon on the screen, or you can draw individual lines, or you can draw rectangles, round rects, circles, things like that. But making a graph, which is a bit more complicated there, that didn't exist. So there was something called a sparkline that was in that same module for drawing polygons and such. But the sparkline, basically it's like a very simplified line graph, but it doesn't have any axes or anything on it. It doesn't have any kind of tick marks, so that it just shows you
a general trend.
What's the trend been? Has it kind of been wiggling around, or has it been generally going up or generally going down? That's kind of what these sparklines are for. So I ended up writing, again, my own little kind of module there that would create a graph instead. But there was a lot more than that had to go into that. But it was fun to kind of have to think through the logic of, okay, how do I figure out where the tick marks need to be, and how do I auto scale this so it kind of makes sense initially as the temperature is kind of, the room's coming up to temperature versus once it starts cycling, and how do I make it so that it's not just showing me a 3-degree window and there's no ticks on the screen because I have them every 5 degrees or something. So
right, okay.
But yeah, so that was kind of a fun project with CircuitPython, and I enjoyed doing that enough that then I went ahead and picked up, again, from Adafruit, they have the MagTag, which is a ESP32 device that has an e-ink display on it, and it has Wi-Fi.
Yeah, okay.
So my kids are always asking, like, what's the weather going to be like for the day? Some of my kids aren't young enough, or still young enough, they don't have phones. And I was thinking, hey, it would be kind of cool to have like a little display that we just kind of leave running in the middle of the house that would show the current temperature. And again, you'll see trends here and how I tend to think about things with a graph of the temperature, the precipitation forecast for the next day, the 24 hours.
Okay.
And so I was able to pull that together in CircuitPython as well. It goes over Wi-Fi to the Open Weather website, uses their API to get the weather forecast information, and it's free for the amount that I end up using it.
Right. That's something I've looked into recently too.
And it's pretty cool just to put something together like that. And my kids actually, they walk past the little display in the center of the house and they look at it. So, where I grew up having just a thermometer sitting on the outside of the window that I could look at and see the current temperature. And of course you look out and the current conditions, but that doesn't tell you what the high is going to be for the day or at what part of the day it's going to be, what temperature or whatever. So
where are we headed?
It's fun to do that.
That's cool. The MagTag, like, it literally has like a magnet on the back of it.
You can
like, throw it on a fridge or whatever.
It has 4 like mounting holes on it, and then they sell some standoffs with some magnetic feet that you can add to it.
Okay.
So yeah, you could. One of their use cases, is or that they push there on Adafruit. One of their examples they show is you could have the magnetic feet on the back, and then you can put a battery pack on it with a light poly batteries.
Yeah,
and then
right.
And then since it's e-ink, when it's not changing or updating the display, it uses very, very little power for that.
Yeah.
So the battery life then becomes a direct function of, well, how often do you update the display, and how often does it have to go online to use Wi-Fi?
Right. For the weather, it's like, how often do I need to do that?
Yeah. So if you're doing that,
cool. Wi-Fi is probably the most expensive element there.
Yes.
As far as energy use, yeah.
But
cool.
I even started using CircuitPython at work here and there. We had, again, just looking to do some simple, quick and dirty prototypes where we wanted to be able to turn on and off some solenoids or some motors that were just a straight DC motor, and we needed something that we could programmatically switch on and off 24 volts to be able to control these solenoids and have something that could control multiple sets of that.
So has that become like a bit of a toolkit that you have, that you can, like, you have like a handful of little controllers that you can pull out and say, all right, this could work for this situation, like, like a toolbox?
Yeah, we've probably got at least 4 or 5 test setups at work that are using some of these. They're just using the feather to drive those.
Nice. I would imagine in the industry that you're in that precision is like super crucial.
Mm-hmm.
So when building like components and so forth, is it something that you would even do like 3D printing of things to test stuff out, or is it required much more precise machining?
It depends on what we're doing. We use a lot of 3D printing for sure.
Okay.
We have, if you're just making like a bracket to hold something for your test setup, just to hold two things fixed in place relative to each other, then we do 3D printing all the time for things like that. But we also have a machine shop at work, like in the building. So that as we're making prototypes, it's a decent sized place. There's probably 1,000 people there at this building, and we've got a full on machine shop that has 5 or 6 people full time there.
Wow.
And so as we're designing parts and we need to machine something out of aluminum or out of steel or whatever, you design it up in CAD and have the machinist make it for you, which is it's pretty cool as an engineer. That's certainly one of the most fun things, is the first time that you have designed a part in CAD and then you get to hold that physical part in your hand.
It's like Christmas.
Someone just like hogged that thing out of a giant chunk of aluminum, and it's now sitting in your hand. It's all shiny. It's like, this is really cool.
Yeah, that's pretty neat. I feel like we hit a lot of the core ideas that we wanted to touch on. I thought maybe if you want to like share a few of the other projects that you've created that you already kind of put up in PyPI, if you're comfortable with that.
Sure. So I mentioned the scanf module or package there, but there's a couple. Probably the one that I use the most at work is somewhat of it's very specialized, shall we say. But if I'm doing some kind of data processing and I create a graph, it's very, very common to just visualize what's going on there. And then, well, what do you want to do with that graph? Well, a lot of times you want to throw it in an email to someone, or in a chat message, or you want to put it in a report, or something, right? Lots of different ways of doing it. So without this module, what you'd have to do then is, save that out to a file, and then go find that file and, attach it to your email or copy and paste it or whatever. But you have to go, it's a multi-step process there. But a lot of the work I'm doing is interactive, where I'll generate this graph and then I'll make a change to it and generate a different graph. And it's similar to some of the workflows that people would do with Jupyter Notebooks, but I ended up just doing it all in PyCharm.
Okay.
But I found, again, looking online to see, hey, is there a solution for how I can copy a figure from Matplotlib to the clipboard so that I can just paste it into something else? And I found some, Stack Overflow comment that showed how to do it, at least in one way, and then a different Stack Overflow comment that showed how to do it in, say, a different OS or whatever. So I pulled all those together into a package, very, very imaginatively named Add Copy Fig Handler. So it's just a handler that when you hit Control C or Command C if you're on the Mac, it'll copy that figure up to your system clipboard, and then you can just switch over to whatever other app you're going to paste it in and hit paste, and there you go. And it drastically simplifies that process.
And it's specifically Matplotlib.
Yes, Matplotlib
Okay.
Yeah, and then depending on what platform you're on, you either need to be using Qt as the plotting backend, or GTK, I think is the other one that I support. TK, unfortunately, which is the default backend that's supported by Python by itself, doesn't quite have what we need to be able to copy it to a clipboard. So it does require one of these other backends. But I use it all the time, and a bunch of my colleagues use it all the time. And then once I started putting it up on PyPI and on GitHub, I get feature requests, and I was like, wow, other people also find this useful. That's really a good feeling.
Yeah.
I enjoy making tools, not just making a product, but I do like making tools that I use and then that other people use as well. It's very satisfying.
That's my absolute favorite thing of being a programmer, is just like, not even necessarily solving my problem, but creating, like, seeing other people like so frustrated and like just making their life easier and saving them time, and just that sort of appreciation that, you were like magically solving this thing for them, and they're so happy. It's like such a great feeling.
Yeah. So I've got that module up there, and then let's see other things I've got on PyPI. I have some older ones that I don't do a whole lot with anymore.
Okay.
But one newer one that's kind of been a little project for a while, called Canaveral, which is an application and file launcher. So this is kind of one of my more ambitious projects to date as a sort of personal project, where it's PyQt based, and it's similar to something like, say, I think what I'm basing it on was there used to be one for Windows called Launchy that doesn't exist anymore, but it's similar to doing like a spotlight search on your Mac, or say if you're on Windows and you hit the Windows key and start typing, and it searches your menu for you. The problem I was run into, say here's a good example. On Windows, I frequently end up trying to remotely log into another computer using a VNC program called Tiger VNC. So I hit the Windows key, I type Tiger, and what does Windows do? It, so helpfully, maybe 70% of the time, will suggest, you'd like to do a web search for Tiger Woods.
Right.
Like, no, I really don't. I have a shortcut in my start menu for Tiger VNC, but for some reason, it thinks that that's what I would prefer instead.
Yeah. I've had to make a change in my Mac Spotlight things to say, just don't do the web thing, please.
Yeah, it's really annoying. And so, there's lots of tools around for doing this. Alfred on the Mac is great, and some other tools as well. But there wasn't one that I really liked for Windows, and so I started writing one. So being a launcher called Canaveral.
Nice.
And it's all in Python. So it's available on PyPI, although I would recommend probably using a tool like PipX to install it.
Yeah. We had a whole episode about tools to add via PipX.
Yeah, PipX
that's
is very
cool.
PipX is really great. But yeah, so that's
awesome.
If people are interested in checking it out, they're welcome to.
Yeah, there's like about 10 projects or 9 or 10 projects up there that people can check out. So I have these weekly questions I thought I would ask you. And the first one is, what are you excited about in the world of Python?
So the keynote at PyCon about PyScript just blew my socks off. It was so cool. Like just the sheer, not audacity, but it took a lot to do that kind of a live coding demo. That was that. Yeah. It really was trying to tick on and off a lot. And man, he nailed it. So that got me thinking more about, WASM and things that are that with WebAssembly that PyScript uses to accomplish what it needs to do. So I started looking into that and then learning more about this to go along with WebAssembly or WASM. They have this WASI, the WebAssembly Systems Interface, I think. That because WebAssembly, if you're able to run Python code in the browser, which is sort of where this eventually ties back into here, that is running in a virtual machine in your browser. And so if you were able to run that code locally, you would still be running in a virtual machine that doesn't have any way of talking to the rest of your system resources, like your file system, things like that.
Sort of in a sandbox of sorts.
So there's this other standard that they're working on called the WebAssembly Systems Interface, and that then is the appropriate interface then for WebAssembly to talk to other resources on your local machine. Yeah, and that sort of if you combine all these together with something like PyDide, maybe this starts to become has a lot of potential as being a way of being able to distribute Python applications.
That in your field would need that kind of connectivity.
Yeah, and I don't, it's not necessarily that's a professional thing that I care about, but just I'm really excited to see where that goes.
Yeah.
Just because I have tried to make some small utilities, again, whether it's personal or professional, to distribute and use Py2 app or Py2 exe, PyInstaller.
Yeah.
And they can work. They have their limitations in various places, but being able to do something that's even cross-platform through this WebAssembly, that sounds really intriguing to me. So I'm very curious to see what happens with that.
Yeah, I haven't heard of that. I'm definitely going to find some links and connect that stuff up. Awesome. What's something that you want to learn next? In this case, it doesn't have to be Python. It can be whatever.
I've got a number of ideas for little projects. I'm sure that'll be surprising, given. But
what?
But in particular, I mentioned we've got these boards at work that we use CircuitPython to control higher power loads. So you've got your Feather or whatever that just has a 3.3 volt logic output on it, but you want to be able to switch some, say a 24 volt power signal coming from somewhere else, whether that's with solid state relays or FETs or whatever.
Okay.
And we've kind of had to make just hand soldered some custom circuits for doing that in these cases. But I have a number of places where those would be kind of handy, whether that's at work or in hobby uses, where you want to turn solenoids on and off or something, and little DC motors. And I haven't really found any good solutions for that are sort of prepackaged. I want something that I can either is packaged as like a feather wing that I can drop on top of one of these feathers from Adafruit, or a hat that I can put on top of a Raspberry Pi. And the solutions I see are either ones that only handle maybe one or even two outputs, or they're really expensive and they're aimed at like OEM customers because you're trying to actually integrate this into a real product, and they're $100 or something. So I want to learn how to use like a PCB layout tool like KiCad or something, and be able to design like a nice compact board that can handle, 4 to 8 outputs or something, that just has nice connectors. You can just plug a solenoid in and then control it with the PWM output of your microcontroller using CircuitPython. I think that'd be really slick, and it would be something that a lot of people could use in different situations.
I had her on really early in the show, Thea Flowers, Stargirl. She is really deep in KiCad now and doing lots of interesting stuff. So I would definitely check her blog out. I know she had like resources for like learning more about it, but that has been one of those things where I fool around with like soldering guitar pedals and other things together and so forth. Mm-hmm. And I've thought about the same thing. Like, man, I really would like to, because I think I mentioned this on a previous show, but the idea of like manufacturing anything used to be like, you have to make 1,000 and it's going to be, insane. I'm thinking of the days of creating CDs or DVDs or whatever. Yes. And the idea that you can just 1-off, 2-off circuit boards is like insane to me. Like I bought kits to like, etch my own boards, and it was just like this freaking biohazard like situation of creating all this stuff, and then like, how am I going to dispose of this? And so like the idea of just like in the tens of dollars making these boards is just fascinating.
It's absolutely amazing what's out there now. So yeah, that's what I want to learn how to do. It's totally outside my kind of comfort zone. I've hand soldered stuff before, made little circuits, but this would require me to learn both how some of these specific circuits would really need to be made, and then due to layout, that's a whole new area for me. So
and you can do like double-sided boards and all the graphics, and it's amazing. Cool. So how can people follow the work that you do?
Well, they're welcome to check out my GitHub profile or my PyPI profile. Probably there's not as much going on in PyPI, but definitely GitHub that has links to all these different things that we've been talking about today.
Yeah, I'll include links to those.
And if they want to hook up professionally, then look me up on LinkedIn.
Okay. Josh, thanks so much for coming on the show. It's been really fantastic to talk to you.
This has been great. I've been listening to the show for a long time. So, long-time listener, first-time caller.
Absolutely. Cool. Thanks.
Thank you very much.
And don't forget, Deepgram is the preferred speech-to-text API of Python developers. Get accurate transcripts from any audio with features for understanding. Try it by transcribing 200 hours free at deepgram.com. patreon.com/realpython. I want to thank Josh Burnett for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.